Hi, today we will be discussing about a very strong problem-solving technique called recursion. So before we start, let us see what recursion means. So if we type recursion in Google, it shows me an error. It says, "Did you mean recursion?" But if you look carefully, I have spelled recursion correctly. So if I click on this recursion link, it takes me to the same page. So if I click as many times as I want, it redirects me to the same page. So this is what recursion literally means. Recursion is basically repetitive occurrence of some event. And in computer science, recursion means a repetitive occurrence of a function within itself. So if you look at this example, I've written a function xyz. Over here, I am calling the function xyz within itself. So it's basically working like a loop, right? Although a loop can be replaced with recursion or with something that we've seen in the previous slide, but the core purpose of recursion is to solve certain problems having some n number of steps and where at each step we need to do the same task. Now, so I have over here, if you look carefully, I have drawn a diagram that shows that describes an example where my boss asks me to buy him 6 ice creams. And this is what I do. Let me get a little more detail. So, so I have my boss over here, and my boss asks me to buy him ice creams. So the task I'm given is to buy 6 ice creams. So what I do is I'm a smart man and also some lazy. So what I do is I ask two of my friends. So this is my boss here, and this is me. And what I do is and this is the task I'm assigned with. Buy me 6 ice creams. And what I do is I ask two of my friends to get me 3 ice creams each. So I'm not going to the store and getting the ice creams, but instead I'm asking two of my friends to get me 3 ice creams each. And these friends are equally smart, or you can say equally lazy, just like me. And this friend has asked two of his friends to buy him 3 ice creams. One of them will get 2 ice creams to buy, and the other will buy him one. Similarly, it will be 2-1 over here. Now, this friend has 1 ice cream to buy, so he cannot split his work. But this person can further split his work and assign two persons to buy him 1 ice cream each. And the exact thing is happening over here as well. So when a person is assigned with 1 ice cream, these people assigned with the task of buying 1 ice cream actually do the work. These people buy the ice cream from the store. Now, if you notice, if these two, let me use a different color. Okay, so let me use a different color. Now, if these two persons buy one ice cream each, his job is done. Similarly, when these two persons buy one ice cream each, his job is done. And in this step, he was waiting. He bought one ice cream from the store, and now in this step, this person has two ice creams, and these ice creams were bought by his friend. Now, now he has two ice creams, and this person has one ice cream. In total, there are three ice creams, and the job of this person is done. And the same thing is over here as well. And when my friends have three ice creams each, they give me the ice creams, and I finally have all the six ice creams that I needed to buy for my boss. This is what recursion means, or this is what happens when we say recursion in computer science. So let us look at the steps. So there are a few things what we need to discuss. First of all, first of all, the problem statement, or we can say the original task, and it was to buy ice creams. The initial problem size was 6 because my boss had asked me to buy 6 ice creams for him. And the recursive task was to buy ice creams. As I mentioned before, recursion is basically repeating the same task, and the task was buying ice cream. So at every step, everyone is doing the same task. But if you notice, at every step, the problem size is getting smaller. So when the problem size gets small enough or reaches the smallest unit where it cannot be broken down further, we call that unit the base case. And that is where we stop the recursion call. So if we look at the diagram again, so these persons were assigned with the task of buying one ice cream, and there was no way they could split the work, and they had to do the work. These are the base cases, and this is when there was no more function calls. Okay, so let us go back to the slide. So recursion is used in graphs and trees, something we will cover later in the course. And recursion is the base of divide and conquer. All right. So we will get into more details in the following lectures. So that is the end of today's lecture. Thank you very much.